Let's try this trig substitution again. So here we're looking at an example, integral x cubed over root 1 plus 9x squared. So notice u substitution won't work on this. Well, won't work well. We could break that up as x squared x cubed, and the x could be part of your du, but then you've got an x squared left over on top. So this looks like 1 plus tangent squared is the identity, it looks like, because it's 1 plus a quantity squared. So the ones match up, so our substitution here is going to be that 9x squared has to equal the tangent squared. Take square roots on both sides. 3x is equal to tan theta. So x is going to be 1/3 tan theta. And then your dx is going to be 1/3. And derivative of tangent is secant squared theta and d theta. So let's start changing our integral over. So on the top we got an x cubed. So that's going to be 1/3 tan theta cubed. So 1/3 tan theta, whole thing's cubed. In the denominator, 1 plus 9x squared is 1 plus tan squared. So under the root, 1 plus tan squared, set it up that way. And then our dx, 1/3 secant squared. So now 1 plus tangent squared is secant squared. So this will be integral. And the numerator, let's cube the 1/3, that's 1/27th. And then cube the tangent, tan cubed theta. And now square root of 1 plus tan squared is square root of secant squared theta. And then we've got a 1/3 secant squared theta d theta. So the 1/3 and the 1/27th, that's 1/81. Let's go ahead and bring those out in front. Got integral tan cubed on top. In the denominator, square root of secant squared is just secant. Square and square root cancel. And we got a secant squared on the end. So this secant will cancel one of those, and we are left with 1/81. And then integral tan cubed secant is what's left. So now it's a trig integral. And we don't have a secant squared, but we do have a secant tangent that we can pull out, and that's going to be your du, which means u is going to be secant. So here we're going to let u equal secant theta. Du is going to be secant theta tan theta. So let's see, you need our 1/81 out in front. So we break off a secant tangent, we'll have a tan squared theta left over. So tan squared theta, secant theta tan theta, d theta. So this is going to be our du, using the method of the last section. And then the tangent we need to write in terms of secant. So 1 plus tangent squared is secant squared. Tangent squared is secant squared minus 1. So this will be 1/81 integral secant squared theta minus 1 times secant theta tan theta. And now we can go ahead and use this substitution. So 1 over 81 integral u is secant, so that'll be u squared minus 1. And here's our du. And we know how to do that antiderivative. So 1 over 81, just using power rule here, antiderivative u squared will be u cubed over 3, minus antiderivative of 1 is u, and then plus constant. So we got our antiderivative. So now we need to change back to secants, and then we need to change back to x's. So got to reverse two substitutions. So this one was a little bit more involved. So we will have a 1 over 81 out in front. U is secant theta. So inside there, that's going to be 1/3 secant cubed theta. And then minus secant theta is our u right there, plus c. And now we need our right triangle to go ahead and change this back to x. So get our right triangle going here. Theta. And tangent theta is 3x. That's our substitution here. So tan theta is 3x, which you can write as 3x over 1. And tangent is opposite over adjacent. So in relation to theta, we want to make 3x the opposite side and 1 the adjacent side. So then your hypotenuse here will be 1 squared plus 3x quantity squared. So 1 plus 3x quantity squared, and then square root. So that's square root of a squared plus b squared. And that is root 1 plus 9x squared. And then look here, if you go back to our original problem, right there's our root 1 plus 9x squared. So that's confirmation that we're set our triangle up right. And so now we just need an expression for secant theta. Well, secant is 1 over cosine. Cosine is adjacent over hypotenuse. So secant theta is going to be hypotenuse over adjacent. So hypotenuse is the root 1 plus 9 squared. Adjacent is 1. So this is going to be root 1 plus 9x squared is our secant. So we've got 1 over 81 times 1/3. And then our secant gets cubed. Well, secant is root 1 plus 9x squared. And then that gets cubed. And then minus secant theta, root 1 plus 9x squared. Close up our parentheses, plus constant. And then this, if you wanted to, you could write that as 1 plus 9x squared. And it's third power square root, third power second root, so 3/2 power. So those are equivalent, these two. So, and we got it.